Start of a new year, start of first unit we're going to deal with. Before we get into the unit, we should quickly review a little bit about number systems. I think you're going to remember this fairly quickly. We kind of have labels for different numbers. The first type of numbers just are counting numbers. We call those the natural numbers. So here's the natural numbers. Okay, if we put a 0 in front of that, that group becomes a little bit of a larger group, which is called the whole numbers. Okay, by the way, I said larger group. That's a little bit strange. Really, it's not a larger group because, I mean, there's an infinite number of elements in each group. So one is not really larger than the other, but it kind of seems like it is. Okay. Then we have the integers. So if you think about the numbers in the whole number group, if we go the other way and say -1, -2, -3, and we go the other way for infinite distance as well, those are the integers, okay? And then we have what we call the rational numbers. Now those you dealt with in grade 9, those are numbers that can be written as a fraction. Okay, so there's some listed in this group here, 3/4, -9/2. How do you know if a number can be written as a fraction? Well, one thing you can do is you can try it in your calculator, but a lot of times you don't have a calculator. So how do you know if you can put it as a fraction? Well, why is 11.23 a number that you can put as a fraction? Well, you know that 23 as a decimal is 23 over 100. Okay, what about a number like 7.12 where 1/2 is repeating? How come I can put that one as a fraction? Well, the rule there is actually that you'd go over 99. You can try that. 12 divided by 99, if you put that in the calculator, it's going to be 0.1212 going on forever. Okay, so those are what we call rational numbers. Any number that doesn't fit that group is called an irrational number. Now, if you think about an irrational number, it's basically a decimal that never terminates, in other words, never ends, and there's nothing that's repeated. Okay? So the one I just gave you, 7.121212, the 1/2 is repeating. If I were to say 1/2 you see the difference there? This one can be written as a fraction, this one can't. Okay? Because nothing is repeating there. So those are what we call the irrational numbers. Now, why do we care about these numbers? These numbers are called the real numbers, all of these numbers. They're basically any number you can think of. I mean, if you took a number line here, and you took any of these numbers, say √2, where is √2? Well, √2 is going to be somewhere between 1 and 2. It's somewhere on the number line. Every single number line value is called a real number. Now, there are a few numbers that wouldn't fit on a number line, but you will not deal with those in grade 11 or 12. What number doesn't fit on a number line? Well, the imaginary number. The imaginary number is the root of -1. Okay, we don't deal with those numbers, but that's what would fit there. You guys are just dealing with real numbers. Okay, so let's move into the first concept that's new. This idea of an absolute value. The absolute value I like to think of as the distance the number is from 0. So for example, 2. What is the absolute value of 2? Well, here's 2. What's the distance from 2? It's 2. What about -2? Well, here's -2. What is its distance from 0? It's also 2. Okay? So the absolute value, think of it as being the distance from 0. Another way of thinking about it is that it's always going to be the positive value because distance is always positive. Okay? So let's do the first one. What is the absolute value of 4.2? The absolute value of 4.2 is 4.2. Not very complicated. What is the absolute value of -6.1? It's 6.1. What is the absolute value of -3/4? It's 3/4. what is the absolute value of negative 1/2? It's 1/2. Okay? So that's how to evaluate them. Now let's order these numbers from least to greatest. Well, which one of these numbers is the smallest? I think 1/2. So let's put 1/2 here. This is the absolute value of negative 1/2. That's the smallest one. Okay, what comes next? I think 3/4. So let's put 3/4 right here. The absolute value of negative 3/4 would go there. The next one would be, I guess, 4.2. And then the last one would be somewhere over here. This is the absolute value of negative 6.1. Okay, so that's kind of a little introduction to absolute value. Okay, so the absolute value of a negative number is the opposite value, in other words, the positive value. Okay, we can use absolute value. You know, this is not a big part of the course, but one of the things that you can use absolute value for is to find distance. And you know, when you're finding distance between 2 points, you're always subtracting one number from the other. And sometimes you're not sure, should I subtract the first one from the second or the second from the first? Well, here's how we're going to use this. We'll show you how this works. Okay, take a look at these two numbers. If I want to know the distance between those two numbers, I can put them on the number line, and I can see approximately where they are. Okay, and if I wanted to find the distance there, I mean, I could figure it out one way, but another way to do this is just to take the two numbers and subtract them. And since we're finding the distance, take the absolute value of that. Okay, now that's going to be one way. The other way to do it would be to take the absolute value and subtract them in the opposite order. And I'm going to show you how those are going to give you the same values. Okay, so let's try the first one. So I'm going to leave the absolute value symbols here. What is negative 3.7 plus 8.5? All right, that's going to be 4.8. Okay, and what is the absolute value of 4.8? It's 4.8. Okay, let's try this one. What is negative 8.5 plus 3.7? That's going to be negative 4.8. And what's the absolute value of negative 4.8? 4.8. Okay, so either one works. You can try this one. Let's take a guess. It doesn't matter. Let's write them in the same order. We're going to take away the second one from the first one. And since we're finding distance, we're going to take the absolute value. So let's change them to improper fractions first. This is going to be absolute value of 14/3 plus 28/5. And the common denominator is going to be 15. So this will be 70, and this will be 84. So this is going to be 154/15. Okay, and you can leave it like that. I like that better than a mixed number. You could try to reduce that fraction, but I don't think it can be. All right. So that's the first little bit of the absolute value. I'm going to show you another place where the absolute value shows up, but this is more of a concept than a strategy for solving things, because I don't think you're going to need this to solve these kind of questions. All right, we have something called the principal square root. You know that 5 squared is 25 and negative 5 squared is 25. That means the root of 25 is 5 and negative 5. But we don't use this. Okay, that never shows up in math. And the reason for that is you don't think about negative 5 times negative 5 equaling 25. We just don't, it's not part of what we think about. We always think that 5 times 5 is 25. So the principal square root of a number is always going to be the positive value. Always the positive value. Okay? It's something to keep in mind, and let me show you where that might show up. Okay, so by definition, the non-negative square root of a non-negative real number is called the principal square root. So what you're going to do is you're going to take the square root of this and always take the positive value. Okay, the example we just had there is if you have the square root of 25, another way to write that would be the square root of 5 squared. And so this is going to be plus or minus 5, but we're always going to take the positive value, the absolute value. So this will always be 5. Okay, well, how does that play out? Well, I'm going to show you how we can use that in this example. First of all, I don't think you would ever use this strategy. I think you would just do the math. I think you would say, okay, what's 3 minus 5? It's negative 2. And then if I go negative 2 squared, this is the square root of 4. And then this is 2. This is what you've always done, and it'll always be okay to do it that way. Okay? But I also want you to consider this. When you have the square root of a square, the square root of a square, a lot of times we think about this and we say, oh, the square root cancels the square, and you end up with just 3 minus 5. This is actually true. You do end up with 3 minus 5. But I want you to remember that we always have to have a positive value come out of here. Okay, and so you're going to get the absolute value of negative 2, which is 2. Okay, now this idea that what's in the square root is always positive is something we kind of intuitively know, and it's going to show up in one weird example that I will show you in the next day or two. Don't worry about it. I will not evaluate on it, but it will be in some of your homework. Okay, we'll talk about this a little bit in the next couple days. For now, here's what you need to be able to do. You need to be able to evaluate absolute value. Okay? So take a look at this question. When I see this question, it looks a little bit confusing because I see these absolute value markers, but I'm not really sure what they apply to. So my advice to you is think of them as being brackets. So even though it's not written, this is actually the opening of a bracket, and this is the closing of a bracket. And then this one is the opening, and this is the closing. That's going to help you know what is actually being affected by the absolute value. Okay? So we're going to have the absolute value here of negative 26 plus 13. This is negative 13. Then I'm going to write minus 2, and then I'm going to have absolute value of negative 6. Okay, now again, this looks a little tricky, so I'm going to remember open, close, open, close. So let's do the absolute value of negative 13. That's 13. Minus 2. And then 6. The absolute value of negative 6 is 6. So this is 13 minus 12, which equals 1. Okay? This is a tricky question. Make sure you try a few of those because there will be a couple on your test, I guarantee you. Make sure you've tried them. All right, let's do this one. So we'll put a 2 where the x is. All right, and then we'll use our order of operations. So this will be negative 2 times 4 minus 3 times 2 minus 4. And then again, multiplication comes next. And then you have the absolute value of negative 18, which is 18. Okay, notice I don't get rid of the absolute value until I have nothing else to do. All right, here's a few questions for you to try. So this is the homework for today. Before tomorrow, I would really like you to try and do some of these simplifying radicals. That's the review from grade 10. You need to know how to do those. If you can't remember, we'll talk about them tomorrow, but you might want to try doing a few of these as a review. Okay? Good luck with that.